If you've been watching some of the recent Subcontrabassoon live streams, I've mentioned some things that I'm planning on working on next. One of the items that wasn't on that list was Padcups. But as it turns out, my dad ended up needing to buy some 2-inch brass for one of his jobs. And since he so rarely needs brass, he mainly works in stainless steel. I thought it would be a good opportunity to go in together, buy enough brass for both of us, and he could make his parts, and I could make my pad cups. So that's what I did. And here they are. 27 custom machined Subcontrabassoon pad cups, ranging in size from the giant 70 millimeter or 72 millimeter pad cups to fit a 70 millimeter pad for the low B flat and B tone holes, all the way down to the tiny 8.5 millimeter pads, so 10.5 millimeter pad cups, for the octave key vents. Now there are two very common ways to make pad cups. The first would be forming. So in this approach, you would take a sheet of brass or nickel silver and you would stamp it into the shape of a pad cup. Now this is great if this is fast and inexpensive if you're making a lot of a specific size of pad cup. But in my case, I needed 20 different sizes of pad cups and only a few in each size, or one. Most of them I only needed one of. So for me, it was actually less expensive to machine these out of solid brass. All in all, I started with about 6 kilograms of brass round bar and ended up with about 500 grams of pad cups. So it's not the most material efficient approach, of course, because you're losing a lot of material machining something this thin out of a solid piece, but it did end up being financially the most efficient approach for my needs. So this is what one of these pad cups looks like in action. So this is my custom Subcontrabassoon pad set that was graciously donated by Music Medic. And so there is one of the 70 millimeter pads. This is actually the largest pad Music Medic was able to make, that Music Medic had tooling for. I was kind of aiming for maybe a little bit larger, like 72 millimeters, but 70 will work just great. So, and then so this is the runnus joint. This is the tone hole for low B flat. And it's gonna look something like that. And here's kind of a more medium-sized pad and pad cup for the low G tone hole. And then of course the little baby pads for the harmonic vents. Yeah, but I may actually end up switching these out with cork. Haven't decided quite yet. Now I do have a time-lapse recording of the machining process of one of the pad cups, actually the 68.5 millimeter pad cup for the low C tone hole. But before I show you all that, I thought you all might like to see a kind of a more in-depth explanation of what I'm actually going to be doing using this animation I've prepared. I'll be starting with a piece of round brass stock. For most of the pad cups, I started with 2 inches. For the larger pad cups, I needed some 3-inch, and for the harmonic vent pad cups, I used just a little bit of a 3/4 and 1/2 inch that I happened to have lying around. The first step I took was turning down the outer diameter to that of the final pad cup. Then I faced off the front surface. Now on the finished pad cup, this surface is only going to be the edge of the pad cup. So sometimes I didn't finish the whole surface, just the outer edge. Now setting that surface I just defined as my 0 and using the same tool, I removed the material from the inside of the pad cup. And finally, a very light file on the outer edges just to take off the burr. From there, I used a parting tool to remove the pad cup from the rest of the stock. Now, parting tools, especially when you have to extend them far enough to cut 3-inch round material, aren't going to leave a very good surface finish. So even if I wanted to keep the back of the pad cup flat, I was going to need to figure out a way to flip it around so that I could machine the other side. Now, the most obvious approach to flipping it around so to machine the other side would be, well, just take it and put it back in the chuck, or flip it around and put it back in the chuck. There's 2 things wrong with that approach. First of all, for something this wide and flat, there's almost no chance that you're going to get it perfectly aligned again. So the top side and the bottom side would be out of concentricity with each other. And that's not necessarily the end of the world, but the other big issue is for something this thin, I went with a 1 millimeter wall thickness on these. By the time you put enough force on those jaws to clamp it in place, you're probably gonna deform and maybe even crush something this thin. So if I were in a high production environment, it would be worthwhile to make some, a whole bunch of custom collets. Or some tapered collets that could work over, a narrow range of sizes of pad cups. But since I have 20 different sizes of pad cups, covering a very large range, that would have been quite a bit of custom tooling. And since this is the prototype, I'm not even necessarily sure that for a second subcontrabassoon that these are the pad sizes I would use. So I wanted a more flexible approach, and I ended up going with an arbor. Now, the exact approach I used is going to be a little bit weird, and I'll be honest, I did not expect it to work. I started with a simple solution and wanted to rule that out before moving on to what I thought would happen. But as it turns out, the easy solution worked, and this is how that went. So I started with just a piece of 4-inch scrap steel. Ideally, I would have used 3-inch aluminum for this because it would have been easier to machine, but we didn't have any 3-inch aluminum scrap lying around, and the giant piece of 4-inch is what we had. From there, I faced off the front surface and then machined a shoulder so that the diameter of this shoulder was the same as the diameter of the pad cup, the outer diameter of the pad cup that I would be mounting. Next, I machined a second shoulder, this time for the inner diameter of the pad cup. Now, I wanted this to be very close, a very close fit. So you'll see in the time lapse, even though I'm taking measurements, I'm also taking off a few thousandths at a time just to get that fit as close as possible. I don't want to have to force it on because then I'm going to have trouble getting it off. But if it's not close, it'll wobble and won't do me any good. And then finally, just chamfer the edge so that the pad cup, which doesn't have a perfectly square edge on the inside because of the radius of the tooling, just to make sure the pad cup sits as far onto this arbor as possible. Now, originally, I had assumed that I would be supergluing the pad cups to this arbor, and machining from there, you know. But, like I said, I wanted to try the simple solution first, and the simplest solution I could think of was simply using electrical tape. And it worked. In the 22 pad cups I made this way, the electrical tape never failed. I took very light cuts, and it worked. I'm not necessarily suggesting this. This is definitely not the way the pros would make pad cups, but with my setup and my needs, it worked for me. So it was a huge time save on machining the back of these pad cups. Because if I'd had to use super glue, I would have to wait for it to set, and I'd also have to, you know, deal with super gluing my fingers together because I think, well, right now, nitrile gloves are very difficult to come by. So now that the pad cup is flipped and mounted, the first step was facing off the front, or what will now become the top of the pad cup, facing that off flat, so I have a nice true surface to work from. Now there are different designs of pad cups available. Some are flat, some are tapered, some are more complex curved shapes. I ended up going with a simple taper. So in order to do that, I needed to use the compound slide set to whatever angle the taper was going to be. On these particular pad cups, the angles are between 1.5 degrees and 8 degrees, so very shallow angles. And then to finish up, I added a chamfer and then used a file to smooth that chamfer out into a nice healthy radius. This is mainly just for looks. And similar to before, I started with the largest pad cups and then machined this arbor slightly smaller for the next pad cup, so on, all the way down. This way I was only using that 1 inch of material rather than I would have had to use a lot of scrap if I had made a separate arbor for each pad cup. And there we have it. I'm quite happy with these overall. I still need to buff and polish these, although there's not much reason to do that until they get soldered to the key arms, which of course aren't anywhere close to being done yet. I wasn't even planning on doing the pad cups this early, but it just so happened I got the material in advance. But I'm quite confident that these are the pad cups that are going to go on the prototype Subcontrabassoon. So, without further waiting, here is the time lapse of the whole process. Most of this is 8 times speed, although there are some moments that are actual speed when I'm doing something particularly interesting. Anyway, I hope you've all have enjoyed this video. If you have any comments or questions, please go to the comment section below. Otherwise, have a great day and see you all with some Subcontrabassoon updates soon.